Good morning. This is your Stats Sensei, Mr. Spensei, and this is the test review for Unit 3B, the geometric and binomial distributions. Our scenario, at a major music festival, 40% of attendees are randomly selected for special VIP upgrades when they scan their tickets at the entrance. 40% sounds pretty important. The selection process is independent and the percentage remains constant throughout the festival. A sample of 50. Okay, so we know we have a sample size of 50 attendees was chosen to analyze this process. Additionally, festival organizers want to track when the first attendee is selected for a VIP upgrade during sequential scanning. So it sounds like we have a probability of about 0.40, and we have a sample size of 50. So what is the probability that at least 25 attendees of the 50 are selected for a VIP upgrade? So we're not looking for the first one. We're looking for a specific number. And since we're looking for a specific number and not the first one, this lets me know that this is a binomial, and all binomials start at 0. So my number line is going to be 0, 1, 2, 3. In this case, dot, dot, dot to 25, dot, 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 all the way to 50. Because 25 is at least 50 and 50 is at least 50. So this is the group that we're looking for. So my probability statement is going to be the probability that 25 is less than or equal to X is less than or equal to 50. All right. So my formula for the binomial is n choose X, which is my sample size, and an X and probability 1 minus P times n to the minus X. But in this case, I'm going to have to do a summation. And I know I'm doing a summation because I have multiple values circled. So this is going to be the summation, and it's going to be 50, choose 25, the lower bound. Our probability that we said was 0.40. We said that earlier from the scenario. 0.40 to the 25th times 1 minus 0.40 to the 50 minus 25 plus dot, dot, dot plus 50, choose 50, and then 0.40 raised to the 50th times 1 minus 0.40 to the 50 minus 50. All right, let's plug that into the calculator. So because it's a summation, I'm going to have to go to math. Summation X equals the lower bound of 25, the upper bound of 50. Second vars, binomial PDF. Trials in this case were 50. Our probability is 0.40. And because this is a summation, we're going to have to use an X for our counter. And our answer is 0.0978. Okay, next one. So our next problem, problem number 2, what is the probability that 20 attendees out of 50 are selected for a VIP upgrade? Well, this is specifically 20. This is not looking for the first, so I know I'm looking for a binomial. All binomial number lines start at 0. So 0, 1, 2, 3, 4, dot, 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 to 20, dot, 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 all the way to 50. And I'm only looking for that value. So since I'm looking for a singular value, my probability statement is simply probability that X equals 20. The other nice thing about that is I don't have to do the summation. I just need to plug into the formula. And we know we have a sample size of 50. N is 20. P is 0.40 raised to the 20th times 1 minus 0.40 to the 50 minus 20. All right, we don't have to do the summation, so we can go straight to second vars. Binomial PDF. Trials is 50. P is 0.4, so none of that has changed, but my X value is now set at 20 because we did not use the summation. The X is only for summation. So we use 0.1145. All right. Looking at number 3. What is the probability that the first attendee, there's a key word, first, so it lets me know I'm working with a geometric, for a VIP upgrade is the third attendant. So since it's a geometric, all geometric start at 1. So 1, 2, 3, 4, 5. This goes all the way to infinity, but it has to be the third attendant, so it's just a singular value. So in this case, my probability statement is simply the probability that X equals 3. All right. And we need to look at the formula for the geometric. Well, the formula for the geometric is 1 minus P to the X minus 1 times P to the first. So in this case, we're going to go, all right, 1 minus, our probability is 0.40. Our X value is 3. So 3 minus 1 times 0.40 to the first power. And my answer, to do that, I'm going to have to go second vars, geometric, PDF, probability is 0.4, X is 3, and I don't use the summation because we only had a singular value here. It's 0.144. 0.144. Okay, moving on to number 4. What is the probability the first attendee selected for VIP grade is not found until after the fourth? All right, so we're looking for the first. So this is a geometric. All geometric start at 1. So 1, 2, 3, 4, 5, 6, dot, dot, dot. All geometrics go to infinity. And I said after the fourth. That means we're looking at 5 because 4 is not after 4, but 5 is after 4. All right, so 1, 2, 3, 4, 5, 6 to infinity. 5 is after it, so that's what we're looking for. Now, anytime you circle infinity, you're going to have to do the 1 minus statement. So 1 minus the probability, and you're going to have to subtract out what we don't want, which is this area right here. So 1 minus P to the 1 is less than or equal to X, less than or equal to 4. So we're going to have to subtract out what we don't want. Also, when we go to our plug, we're going to start off by going 1 minus, and this is where we're going to do a bracket. And we have multiple values, so I have to use a counter. All right. And my counter is going to go from X equal 1, because that's the lowest value I'm subtracting out, to 4. From that point on, I need to refer to my formula, which in this case is 1 minus P. So 1 minus 0.4 raised to the first power, because we start at the lowest, times 0.4. Oh, 1 minus, make sure I subtract 1 because that's what's in the formula. 1 minus 1 times 0.4 to the first power, plus dot, 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 plus 1 minus 0.4 to my highest value, which is 4. 4 minus 1 times 0.4 to the first. All right, so here we go to run this thing. 1 minus math, because I need the summation, so I have to get that summation from math. X equals, well, we said X equals 1, that's our lowest value, to our highest value of 4. Then second vars, geometric PDF, probability is 0.4, but our X value, we use a summation. Anytime you use a summation, we have to have X here, because that operates as a counter, because it says X can be 1, X can be 2, X can be 3, X can be 4. And we end up getting 0.1296. So the answer to number 4 is 0.1296. All right, looking at number 5. What is the probability that no more than 18 attendees of the 50 are selected for a VIP upgrade? So my number line is, first off, this isn't a first. It's out. We're looking for a certain number. The number is attendees. And so if that's the case, it's a binomial. So 0, 1, 2, 3, dot, 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 18, 19, dot, 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 all the way to 50. Well, no more than 18. Well, 19 is more than 18, but 18 is not. So I'm looking for these values. So this is the probability that 0 is less than or equal to x is less than or equal to 18. All right. Well, we know it's a binomial, and I have multiple values, so I know I'm going to have to use a summation. So it's going to be the summation, and it's going to be using the binomial. Our sample size was 50. Our lowest value is circled as 0. 0.40 is our probability to the 0 times 1 minus 0.40, to the 50 minus 0 plus dot, 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 plus 50, and our highest value was 18. 0.4 to the 18th times 1 minus 0.4 to the 50 minus 18. All right, let's take a look at that. So we're going to run that on a calculator. And remember, we use the summation, so we have to go to the math button. Math, summation, x equals low value of 0, upper value of 18, second vars, binomial PDF. Trials in this case was 50, probability is 0.4. And since we use the summation, this has to be an x. And we end up getting 0.3356. All right, moving on. So moving on to question 6, if I can get there. Pages are a little sticking together. All right. And question 6 says, what is the probability that the first attendee for a VIP upgrade is found among the first 3? So first and among the first 3. All right. So I see the word first. So this tells me, hey, you're probably working with a geometric. Geometric start at 1. So 1, 2, 3, 4, 5, dot, dot, dot. All geometrics go to infinity. And it says among the first 3. So I'm looking for this group right here. So I'm doing the probability that 1 is less than or equal to x is less than or equal to 3. And we need to look at my geometric formula. Which is 1 minus p. So in this case, once again, 1 minus 0.4 or 0.40, it's up to you. And my low value, and by the way, I have multiple values circled, so I'm going to back up here and make the summation. So I have multiple values, so I'm going to put a summation, and I'm going to go 1 minus 0.40 to the 1 minus 1 times 0.40 to the first. So that's the first one. That's our first value. Plus dot, 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 plus 1 minus 0.40 to the highest value. So 3 minus 1 times 0.40 to the first. All right. So we use the summation. So, we had multiple numbers, so we use a summation. To do that, I go to math, summation. X is 1 to 3, second vars, geometric, PDF, trials, the probability is 0.4. And since we use a summation, we have to use an x. Multiple values, we're going to use the x. So 0.784. All right, moving on to number 7. What is the probability that between 15 and 30 attendees of the 50 are selected for a VIP upgrade? So we have 15 to 30. All right. And we're not looking for the first, we're looking for multiple attendees. This lets me know where it's binomial. All binomials start at 1. So 0, 1, 2, dot, 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 15, dot, 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 30, dot, 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 all the way to 50. I'm looking for this group right here. So the probability that 15 is less than or equal to X is less than or equal to 30. So when I go to plug in, I know that I have multiple values, so this is going to be a summation just because I have multiple values. And when I consider the binomial formula, it's going to be 50. That's my sample size. We're going to choose the lowest, 15. Our probability is 0.4. So to the 15th times 1 minus 0.4 to the 50 minus 15 plus dot, dot, dot plus 50. Choose our highest value circled was 30.4 to the 30th times 1 minus 0.4 to the 50 minus 30. All right. Please note this right here shows up right here. This right here shows up right there. Just the difference is you put a minus sign between them. All right. We use circled multiple values. So we're going to have to use the math button. Math summation X equals my low bound of 15, my upper bound of 30. Oops. Here, I'll just start over. Math summation. Try again. Math summation. So even the teacher makes mistakes. X equals 15 to 30. There we go. Second vars. Binomial PDF. Trials in this case is 50. Our probability is still 0.4. But we use summation, so this has to be an X. And I get 0.9446. All right. The next one, what is the probability that out of a group of 4, oh, we have a different group size this time, all 4 are selected for a VIP upgrade? Okay, so we have a group of 4, so this lets me know that we're working with a binomial. So my number line, in this case, it starts at 0, 1, 2, 3, 4. It doesn't go to 50 because they said we had a group size of 4. So in this case, N is 4. Don't want to forget that. And they want all 4. So we're circling the value 4. My probability statement is the probability that X equals 4. Well, that makes it nice because from a formula standpoint, I just have to use that. And in this case, it'll be 4, choose 4, then 0.4 to the 4th times 1 minus 0.4 to the 4 minus 4. Well, if I go about that, second vars, binomial PDF. Notice I didn't hit the summation, and I didn't hit the summation because I didn't have multiple values. I only circled one value. So in this case, my trials is 4, my p-value is 0.4, and my x value is 4. And I get 0.0256. All right, number 9. Calculate the mean standard deviation for the number of attendees for a VIP upgrade. All right, we're talking about the number, so this is going to be a binomial. All right, so I need to look at my binomial formulas. And my binomial formula for the mean is expected value equals NP. And in this case, N was that group size of 50 times a probability of 0.40. And 50 times 0.4 is 20. All right. So 20 attendees. My standard deviation formula is N times P times 1 minus P, which in this case equals the square root of 50 times 0.4 times 1 minus 0.4. So 50 parenthesis 0.4 parenthesis 1 minus 0.4. That gives me 12. So equals the square root of 12. And I'm just going to raise that to the half power. And that's 3.4641. All right. Last question. What's the mean and standard deviation for the number of attendees scanned? This is supposed to be a question about the first. What is the mean and standard deviation for the first, to find the first attendee? All right. So let's put to find the first. This is wrong. I'm going to have to make that change, but this is supposed to be a geometric. So it's supposed to say the first. It's written as a binomial. And if we use the geometric, 1 over P is the expected value. So in this case, it's 1 over 0.50. Is 2. Oh, excuse me. 1 over 0.40. So 1 divided by 0.40 is 2.5. So we would expect to have to scan 2.5 attendees. 2.5 attendees to find our first. All right, get the VIP. The standard deviation. Well, the standard deviation has this formula. Square root of 1 minus P over P, which in our case is 1 minus 0.5. That part under the radical. 0.4. Well, I don't know why I'm writing 0.5. 1 minus 0.4 over 0.4. 1 minus 0.4. Take the square root of that and divide by 0.4. And we get 1.9364. All right. I hope this helps, and I hope you study for your tests. Good luck. See you on the next one. Thank you.